Welcome to the podcast, Philip. Why don't you go ahead and introduce yourself?
All right. Thanks for having me on the podcast. It's my pleasure to be here. Actually, let me introduce myself using a slide here, since we're presenting anyway. So essentially, I'm Philippe Derek, and I'm from Belgium, and I'm a web security expert. So I've been doing web security for a very long time. I actually did a PhD specifically focused on web security, and since my PhD, I've been working with developers on helping them build more secure software, helping them protect the applications that they are essentially building. What else? I am a Google developer expert, which is not a relationship with Google per se. It's more of a recognition for the work I've been doing for the community. I've been giving a lot of security talks and workshops and things like that. And I'm also an organizer of the SecOpDev course, which is a yearly week-long course in Belgium focusing on security for developers. Today, I mainly work with developers through my company called Pragmatic Web Security. I teach training courses, I do consulting work, I write secure coding guidelines, things like that. And I strongly focus on modern web security. So essentially things that happen in an API world, in a single page application security world, and in modern browsers nowadays. And that's exactly why I'm here in this podcast, I guess.
Yeah, exactly. I mean, I'm really excited to have you because one of the major challenges in the software, I mean, security is a big area, but one of the areas when you look into the breaches these days is the API side and also how you consume the web applications these days. So I actually wanted to start just having a little bit of a broader conversation when we talk about the client-side security and this general term called the server-side security.
It's definitely something that has evolved over the years, but yeah, I think the distinction is more than relevant today. So we still have a very strong separation between client and server, and in a sense, the separation is even getting more distinctive, because back in the old days, when you had a traditional web application, essentially everything happened on the server side. The server processes a request, performs a certain operation, generates an HTML response, and sends that back to the browser for rendering. And the browser was nothing more than a fancy rendering engine. And things started to change with the introduction of JavaScript. Things got a bit more complex. Client side got a bit more dynamic. But even in the beginning, it was more of a UI feature and not really an application-specific feature. But if you look at it today, we're building real client-side applications. We're using web technologies to build single-page applications, for one, which essentially run in the browser. And as a result, some of the responsibilities that used to be server-side shift towards the client-side. But if you look at I like the fact that you mentioned mobile applications, because a lot of mobile apps today are not native mobile apps. They're just web applications running in kind of a shell browser-like environment, mimicking the behavior of a mobile application. And when you run an application like that, you are playing in a web security landscape, and you essentially have to abide by the rules set out by this embedded browser. And those rules are mostly the same as we see in traditional browsers. So yeah, I do think that client-side security, at least for some aspects, is definitely a major aspect of modern application development.
Great. So with that, I think that's a good segue into my next question. So let's say, I have a web application, we have a front end, and as you mentioned, right, like there's a mobile app, but it's a shell using some sort of like a browser. So let's start with that setup. If you're dealing with that, and let's say I come to you and say, listen, we have this setup. How can you look at this and say, well, these are the things that you should be really, really concerned about on a day one if you make this website live?
Well, I would say you should be on the lookout for JavaScript, essentially. We're building web applications with a bunch of JavaScript nowadays. By itself, JavaScript isn't pretty, but by itself, it's not too bad. But I would say the ecosystem we have created, where we include JavaScript from a lot of third-party sources, and we build our application using all these remote snippets of code, that is something that is causing a lot of problems and will cause a lot of problems in the future as well. We've seen cases like that where, for example, British Airways got a credit card skimming attack about a year ago or a bit less. And it also affected their mobile users because their mobile app was nothing more than their web application running in the browser. So essentially, we're dealing with third-party code. That code can change under our nose without us realizing. And essentially, at that moment, our application is pulling in malicious code, and that malicious code can do anything at once because the browser honestly wasn't built to handle scenarios like that very well. Let me show you an example of what I think is part of the problem that we essentially have put ourselves in today. So if you have an application, this is one of my training applications I use for an example. It's a Restaurate. It's a simple application to show restaurant reviews. But a simple application like that is going to host user-provided content. This might be some HTML code that the user can use, but a malicious user might also be able to inject some JavaScript in there. We're also using all kinds of JavaScript libraries and services. How many sites do include Google Analytics? Quite a few of them. And essentially what you do when you enable that is you pull in a snippet of code, or you put that into your page, and it's going to pull in some additional code from Google, and it's going to start running analytics. And then finally, we are including third-party components, things that enable certain features in a very handy way. For example, if you're building a site where you want a support widget so people can chat with your support crew, there are plenty of components that offer exactly that out of the box that you can simply integrate. And the problem is when one of these snippets of code, one of these pieces in our application goes bad, we're in trouble because the browser doesn't have an isolation concept. The browser doesn't know that these JavaScript components should be running separately from the main application. And essentially all that code runs within the same application context. So this means if one of them turns bad now or in the future, the whole application runs the risk of being compromised.
So in this setup, right, I mean, this is a great visual to look at. What can you do to prevent like an app not to get compromised? Like, is it a set of practices you should follow? Is it a tool set? I know there's a OWASP top 10 list, and then there are certain tools. Like, what you should be doing to make sure that on a day one within your software development practice, these issues get caught.
Yeah, this is a freaking nightmare. There's a couple of things you can do, but it's not a very easy ride. So essentially, let's talk about user-provided content. That one is probably the easiest to address in a sense that we know that the problem there is cross-site scripting or HTML injection attacks, and we kind of know how to solve them. It's hard solving them because they occur in so many places. Essentially, everywhere you put data into the page, you might have a potential problem. So you need to apply a potential defense. It used to be horrendously hard in server-side applications because you needed to do that on the server, but it's getting better in modern client-side applications such as Angular apps, where Angular handles a lot of that out of the box. The other things are a bit more tricky. I can tell you not to use JavaScript libraries, but if you're a developer and I tell you don't use jQuery or whatever, you're going to be like, yeah, whatever, go away, security man. Because people actually want the libraries. If I tell you to build your Angular app without using Angular, it's not going to be very productive. And we definitely don't want developers writing all of that themselves. Same for third-party components. You actually want to integrate them. It's just really hard to do that in a secure way unless you jump through a lot of hoops. And that's what I meant earlier with my comment that browsers aren't really built for this. There's no isolation mechanism for JavaScript. There's no easy way to tell the browser, I want to run this script, but honestly, I don't need that in my main application context, so just run it in some kind of a sandbox separately so I don't get bothered if something goes wrong. We don't have those controls in the browser. We can do that by implementing something ourselves, but essentially it's kind of tricky and it requires a lot of effort to get that far, even though that would be the only real way forward, in my opinion.
So in your experience, do you think that there are certain browsers that are better equipped when it comes to dealing with security than others? Or they are basically the basic is like the same because of the engine they use?
That's a good question. I'm not a big fan of browser bashing, so let me give you a carefully crafted answer.
That's right.
I think cross-browser compatibility is getting significantly better. There are older browsers. Let's call them what they are. If you have IE11, for example, supporting that is not going to be fun because it's an old browser. That's just the truth, even though it's still used quite a bit. So especially in an enterprise environment, there's plenty of enterprises still stuck with IE for certain applications, some even IE 10, which is even worse in compatibility aspects. So yeah, these things are still around and still need to be supported. So that's a bit of a problem. That said, modern browsers are doing a lot better. So if you have Edge, Chrome, Firefox, Safari, these browsers are actually doing quite a good job, and they are fairly compatible, especially what security is concerned. You have a big difference in the sense that some browsers are kind of the front runners of the pack. So Chrome and Firefox are actually often implementing features as the first ones, and the other browsers are following at a bit of a slower pace. They're kind of seeing what sticks around before they go through the effort of implementing that, and that would be Edge and Safari. Even though I'm not entirely sure how Edge is going to evolve when they move to the Chromium code base, but we'll see how that goes in the future. But in all fairness, all modern browsers are doing quite a good job security-wise. There's a lot happening in the landscape, and a lot of crucial features are supported across all browsers, and that is definitely amazing to see.
That sounds great. I do have a question about the storage of the content itself. I don't know, it probably goes into that user-provided content. So when you browse the website and you enter some information, those are normally stored in a cookie. But now we have this concept of in-browser databases, I guess, like a SQL-like database. How that fits into all this? Because you're storing the content, and then you're browsing through different websites. Is there a security vulnerability right there because some other script can read or even potentially write to that data?
Yeah, there's a couple of things going on there. First of all, browsers do not support SQL, fortunately. There has been this brief period in time where they tried to introduce something called Web SQL, but that got killed really, really, really quickly. So let's consider that a good thing, probably. But you're right when you talk about SQLite under the hood. Browsers, well, it's an implementation detail, but for example, Firefox uses SQLite under the hood to store browser-based data, but it's not exposed as SQL. It's exposed through a certain JavaScript API, of which web storage, or known as local storage or session storage, are the easiest examples. So yeah, that's definitely a feature that's available in browsers today, and there are some concerns with using those mechanisms. So I think this might be a good time to go into a bit of detail there. So what I really want to talk about now is how the browser can handle data in a more secure way. So we have a backend somewhere, and the backend has a piece of data. And what essentially is going to happen is that the browser is going to send a request, get a response that contains this secret or sensitive piece of information, and the browser will need to figure out how to store that. I'm explicitly not defining the piece or the secret or the piece of sensitive information, because it can be anything. It can be a sort of a token that gives access to resources in the backend. It can be sensitive user information that you want to store securely to ensure optimal privacy. It can be anything else you want to keep in your application. What it is isn't really important, because we're not going to talk about what the data is. We're going to talk about how we can ensure that the data is stored in a way that we can provide optimal security guarantees. And the first example to talk about is local storage. So let me explain to you how this very simple, very straightforward mechanism actually works. So if you have a browser, we're going to use reside.com as the example. Browsers have these different contexts. So whenever you load a page, under the hood, the browser will associate an origin with that. And the origin in this case is HTTPS reside.com and 443. It's something that's derived from the URL, and it essentially means that paths or whatever don't count for this. Only the host name is used along with the protocol and the port, which is in most cases today HTTPS and 443. What's happening is when this page runs a script, as you can see right here in the page, that script code can store something in local storage, or retrieve information from there. Local storage is something internal to the browser. It's a browser-based storage mechanism that's associated with an origin. So essentially what this means here is that every context with the origin HTTPS reside.com and 443 will have access to the local storage area, which is also associated with that particular origin. So this piece of script can do local storage.getItem with a specific key, and it will get the value that belongs to that item, which is our secret, as you can see here. This is a very simple, very straightforward mechanism, easily accessible, absolutely awesome and easy to use. There is, however, a small drawback of this mechanism, and that drawback is that any context within that origin can access that data. And this means that if you have another page of the same application with some malicious code in there, that malicious code will also be able to read the data in local storage. There's essentially no way to restrict access because access is governed based on that origin. And these examples are rather abstract, but let me make this concrete. If the top left window would be our main application, and the bottom window would be an error page that contains a vulnerability, that error page, which has nothing to do with the application, would be able to read that local storage area and would be able to steal all the data. And this means that the moment the attacker can make something bad happen anywhere in the origin, they will be able to read all the data in local storage without you having any say or any control over this. And that's the downside of this very widely and easily accessible storage mechanism. So if you want to make this a takeaway for people listening to the podcast, if you're using local storage, it's very easy to use, it's very accessible, but it's mainly useful for long-term storage. It's persistent, but I would say for non-sensitive data. If you have something that you're like, oh crap, if somebody is able to steal this, we are in a lot of trouble, or we risk huge privacy fines because we're leaking information about our users, you might want to consider using something else than local storage.
Okay, so that's interesting. I mean, in the flow, when you show that the local storage is, I mean, the capacity at which it's going to store is one, and the other is the nature of the content that you're going to store. Does it provide like any capability for like non-tampering? Like if you compare that with a full-blown SQL server, for example, right? There is a certain mechanisms you can implement on the SQL side. And I'm assuming it's not going to be the same case, of course, because this is just tiny, local storage. Like it's definitely stored somewhere on your hard disk, right? Like, or is it just in memory?
No, this is persistent storage on the hard drive, absolutely. If you're worried about somebody getting direct access to the data, we can talk about that in a second.
Awesome. Yeah, no, that'll be great. And so in order for this to be resolved, what we should be doing, because this seems like this is really a default scenario, right? If I do nothing, this is going to be all working and this issue will exist.
Yes, so this is actually what a lot of people are doing because it's one of the most straightforward ways of doing this. And it's true to say that if you have a cross-site scripting vulnerability, you already have a problem. In my opinion, that's definitely correct. So once something bad happens in your origin, you are in a world of trouble because the bad code can not only steal data, it can also abuse permissions granted to your application, change the UI, trick the user into doing stuff they shouldn't be doing. But I'm just saying that data in local storage is by default exposed to everything that happens in that origin. And that might be something you want to consider of addressing when you are storing really sensitive information in there. There's an alternative to local storage, by the way. There's something called session storage, which is a very similar mechanism. It's part of the same spec, but it's non-persistent and somewhat limited storage. So let me walk you through how that works in practice. So we have the same setup. We have our browser window with an application or restograde application with the origin https restograde.com 443. When we store something in session storage, it's the same kind of ways of doing that. It's set item, get item API, very straightforward. The difference here, if one of the important differences is that session storage is not necessarily accessible to the entire origin. It's only accessible to this particular context and its direct associated browsing contexts. So for example, if this page, well, let's call them A, this is a set of contexts called A. If this page would open a pop-up, that pop-up would belong to the same set of browsing contexts. If it runs in the same origin, it will be able to access this particular session storage area. So that's good. Let's say that the user now opens a new window in the browser and navigates to a totally different part of restofgate.com, or maybe gets the error page from before or whatever, it's not associated with the previous set of browsing contexts, hence the identifier B here. And when that malicious code tries to access session storage, it actually gets a separate session storage area associated with the same origin, but with a different set of browsing contexts. So essentially, it's called session storage because the spec writers see a set of browsing context as kind of a session that you're doing something in as a user, and you can actually store data for the duration of that session. So another takeaway here is session storage is accessible to a set of browsing contexts within an origin, and it's useful for easily accessible data storage during a session, but not for persistent storage. So essentially, when you close your browsing context, the browser will also close or remove that associated session storage area.
Okay, makes sense. So now if you compare this to the local storage, I think the pros and cons that you said, this is temporal, so it will go away. But then there's definitely a improved security here. So if you look at it from that angle, it's slightly better. Is that a fair assessment?
Yeah, actually, it kind of is. So I would say this is a significant trade-off between security and usability. So it is a bit more secure for sure. That's definitely good, but it's also a bit less useful in a sense that it might exhibit some behavior that you actually do not expect or do not want. So that's kind of a trade-off. In practice, session storage is not used that often, and most applications actually do use local storage.
Okay, got it. Yeah, usability probably supersedes security.
Especially if you rely on behavior such as the user opening a new window, going to the application again, and still being logged in. That wouldn't work very well with session storage, but it would work with local storage. So that's one of the examples of why this actually matters somewhat. But yeah, these solutions are, neither of them are actually ideal. And there's if you really wanna store sensitive information and you want to go the extra mile, there's a pattern you can follow which leverages a browser-based security policy to isolate data from the application and make sure that you have some control over who can access what data. And to explain that, let me first explain the concept of the same origin policy. The same origin policy is a browser-based security policy that has been there for 20 years and is supported in every browser. And it essentially says that if you have two browsing contexts and they interact, they have the same origin, they can freely interact with each other. So if you have a page in the browser, for example, restofgate.com, and it includes an iframe, which is also from HTTPS restofgate.com and port 443, they have the same origin. So the browser will allow these pages to do whatever they want. They can inspect each other's DOM, they can send messages, change JavaScript variables, call functions, whatever they want. There's no restrictions whatsoever. However, the policy also says that if the browser has two contexts with different origins, in this case, search.restofgate.com and private.restofgate.com, those are different domains, so the, one part of the origin will change or will be different. These will be isolated from each other. The browser does not know whether these are trusted or not and will simply refuse the parent from accessing the child or vice versa. There's a few allowed operations, and that's essentially navigating a context or sending that context a message. Those things are possible, but everything else will be blocked by every browser available today. And that's good because it's there because of JavaScript, because otherwise you would be able to be tricked into opening a malicious page. That page would load facebook.com in an iframe and would start inspecting your timeline and reading your messages, which is definitely something that you don't want. And this is called origin-based isolation, and it's a really, really important principle. A lot of security defenses actually depend on this type of behavior in the browser. And we can use exactly this to improve our data storage mechanisms. So let's take a look at what that means in practice. Here's our setup from before. We have our restofgate.com application. Our origin is associated there, but we don't store data directly. Instead, we include an iframe, and that iframe is coming from HTTPS private.restofgate.com 443. And that iframe is gonna run a dedicated piece of code that will grant access to certain stored pieces of stored information. So we have our storage area, which is now associated with private.restofgate.com, and it has our data, and that code can access that data. If the main application would try to access local storage, it would get access to its own area, but it will never see the data stored for private.restaway.com. So this is browser enforced isolation, which is good. These guys can interact. So there's no direct interaction, there's no inspecting the page or calling JavaScript, but the main page can send a message to private.restaway.com. They can ask like, hey, I would like you to perform a certain operation with the data you have stored, and can you give me the result when you have done so? And that private context would be able to do that and return the result. What the computation is doesn't really matter. It could be calculating, increasing a counter and returning the value. It could be calling an API with a certain access token and returning the value. Doesn't really matter here. What matters is that only the private context has access to that information. What happens when something goes wrong somewhere in the origin? Well, the malicious code runs in restaway.com. The malicious code will be able to access local storage, but only its own local storage area. You can see by the origins, this is a different local storage area, and in this case, there's no interesting information in there, so there's nothing to be stolen. To be fair, the malicious code can still include an iframe of the private area and abuse the interface. So it can still load the iframe and ask the iframe, hey, can you perform an operation for me and send me that data in return? The added benefit here is that the iframe can implement kind of an access control policy, because anyone could be able to include that frame. Maybe it's the same frame for restaway.com and admin.restaway.com and protected user interface.restaway.com or whatever. And based on those origins, it can make decisions like, oh, the admin interface, yeah, they can make, they can write data, but the other ones can only read data, and so on and so on. So we're reducing the attack surface from full unrestricted access to local storage to only be able to access certain operations exposed to an interface from within the iframe. And this is essentially leveraging origin-based browser isolation. Let me give you the takeaway here. So essentially, this is one of the ways we can store data in a way that we have more control over who can access that data or perform certain operations with it. And I believe if you're storing truly sensitive data in the browser, that this is definitely one of the patterns that you should be following to ensure optimal data protection. By the way, for the listeners, I'm going to show you a link at the end of the presentation as well, and we can put that into the notes where you have code examples of all of these patterns where you can see the effects yourself and try this out in a modern browser and see how it behaves in practice.
This option here with the with origin-based isolation, is this something that is you get out of the box, or you have to do some extra setting in your browser?
Well, it depends. So you get the same origin policy. Let me go back one slide. You get the same origin policy out of the box. So the blue dotted context is isolated from the green context. So yes, that is what you get. But the code block in that context, let me see if I can highlight this here. So this context here is essentially a piece of code, or this block here is JavaScript code. That's something you have to write. That's JavaScript code you have to write running on private.restaway.com that will listen to messages coming in from here that accesses the data, performs certain operations, and returns the result. So you get the building blocks that you need to make this happen, but it's up to you to implement this in your applications, unfortunately.
Got it. So basically, the threat lies in your own code, right? Like your own code going to return something that should not be returning, then that's on the code itself, right? The mechanism is there. You just need to implement it correctly.
Yes. Well, I wouldn't say that the threat is getting this wrong. I would say that the threat would actually be, or the problem would actually be that most people, first of all, don't know about this pattern. It takes, well, some experience, some security knowledge to actually realize how to fit these blocks together. And second of all, implementing this requires a bit of effort. If you compare this to just using local storage, this is going to be more effort. You have to implement the storage code. You have to deploy that on a separate origin. You have to ensure that it can handle messages and all of that. And compared to simply calling local storage.set item, that's a lot more work. But honestly, I think we need to teach developers how these things work, what the benefits are, so that they actually get inspired to do the work of providing secure data storage.
Yeah, that's a critical point that you just raised right there, because it has to go with the API or the application design itself. Because if you're not going to tackle this at that level, it's never going to be implemented, right? Because this is a design time decision too. It's not something that you can just go and implement. I mean, later on in your code, it'll be hard to implement this if the design doesn't support this, because I can see that these two are completely different domains. It's just a different setup altogether.
Yeah,
So,
absolutely. What I would say here is if you're a developer and you're actually serious about offering secure data storage, I highly recommend building this into a library. So if you provide all the building blocks, high-level libraries that you can include in your restogate.com origin in the green context here, that offers a very similar feature to local storage.set item. It could be storage container dot do this or get that piece of information. If you can abstract that away in a library, it's gonna make this as easy to use as the native storage APIs. But again, it takes a bit of effort to build that into a library. I haven't had the time to actually get that far, but I'm sure if you invest in a bit of time in this, you can actually build a very nice, clean library that you can use across your applications with little to no effort.
all right, good. So I think I'm just looking at my notes here. I think we covered quite a bit. Anything else you wanted to add?
Maybe we can talk about one of your concerns from earlier. So we now have a way to store data in the browser, but even in this scenario here, we're storing data in local storage. So it's isolated local storage for sure. It belongs to private.restogate.com and only that context can read it, but it's still sitting somewhere in the browser. So let me show you what this means in practice. So here we have a very simple example of the local storage API. What we can do is we can do local storage.set item, and it takes a key and a value, and off you go. It doesn't get much simpler than that API-wise. This is an example from Firefox. If you would go inspect your profile data in that Firefox instance, you would be able to find an indexed a SQLite database. It's called webappstore.sqlite, and you can access that from your machine. So you can open it up and look at what else is stored in there. And you can see that the green circled value here. It's a bit hard to read because they have reversed the domain name, but essentially it's for pragmaticwebsecurity.com. That's the domain name, HTTPS is the origin, and it has stored a value called secret and treasure, as you can see there. So our value that we stored in local storage is essentially just sitting there on the disk. This is something that you might want to be aware of, because in essence, this means if the attacker is able to access that data directly, it can still easily be compromised. So here we had our setup from before. We have our origin-based isolation, but we still use local storage to keep the data in a persistent way. And the same thing holds for other storage APIs such as IndexedDB, by the way. But the attacker can now come in and access that data directly. Imagine if you have a bunch of that's stored on your laptop and somebody snatches your laptop and gets access to that data directly, they can still grab whatever sensitive information is in there. So that kind of defeats, or that's a kind of a new threat to client-side storage that you might want to take into account in practice. Protecting against this is a bit tricky. Of course, you have non-web-based measures, so you can tell people to turn on full disk encryption, which would prevent the attacker from directly accessing the disk. So yeah, that's one thing you can do. But you can also do something like that essentially in a web-based context. So modern browsers support something called web crypto, which is essentially a crypto API available in the browser. So what we can do here, you can see that the data has become a lock icon. We can essentially protect the data ourselves, if it's really sensitive at least, by encrypting that. And to do that, we can use the web crypto APIs along with a secret key and store that data in an encrypted way. That way we can ensure that even if somebody takes out the data, when the user leaves their machine unlocked, when a laptop is stolen or a phone is stolen, we still have some level of protection, because without the key, they will not be able to actually access that data. Two practical scenarios to make this happen. So let's talk about how you get the key. And there's two potentially relevant things here. Our first scenario is getting the key from a server. So essentially, we have our context on the browser, we have our backend, and when the user is logged in, they can make a request to the backend to retrieve a user-specific encryption or decryption key. So the backend can provide that key. The key is now stored into that context in memory, and we can use the Web Crypto API to load the key so we can encrypt and decrypt data. Again, all of this is available as a code example in the link you can find associated with this podcast. So this is encryption with a server provided key. Very useful, very straightforward to implement, and very useful to handle data, encrypted data in online scenarios. So where the user is able to access the server, get the key, and decrypt the data stored locally. It's stored in memory, so the moment you close that application context, the key will be forgotten and the data will be protected against device-based access. If you want to do this offline, it's a bit of a challenge, but it's possible if you really need that behavior. So imagine a user that needs to be able to work on the data while being offline and only syncs every now and then. Getting the key from the server is not going to work in that case, but we can get the key from the user. What we can do is we can ask the user to fill out the password, the login form for the application. So the user will likely have an account associated with a password, and we can request that password from the user. We get the password, and then we can use the Web Crypto API to turn that password into a key. There's a very specific cryptographic algorithm for that. So look at the code example if you want to learn more. But essentially, we can turn a short password into a long, secure cryptographic key, and then we can use that key for encrypting and decrypting the data. And the beauty of this pattern is that this works entirely in the browser, and you don't need to do this in an online case. So a password-derived key can be used to essentially access encrypted data or store encrypted data in offline scenarios.
Is there any backdraw, like in terms of performance, that incur during the encryption?
I would say it's probably not going to be an issue because, well, honestly, these storage areas are not made to store like gigabytes of data. The browser is not going to allow you to do that anyway. You're not supposed to fill up the disk just by putting some data into browser-based storage areas. So it's going to be small chunks of data. So no, I don't think there's a big performance issue. There's going to be some implementation effort, of course, to figure out how the APIs work and how to build that into your application. But performance-wise, for the small sensitive parts of information or pieces of information stored there, it should not be a big issue.
I think we cover pretty much all the foundation that that I thought will be good fit for this podcast. Is there anything you wanted to add?
So we talked about a lot of different ways to store data in the browser. So let me recap this into 3 takeaways for this entire podcast. So first of all, the browser is not a place to store secrets. So as we've seen, there's all kinds of threats and dangers, and we can lock it down somewhat by doing a lot of effort, but in the end, there's no definitive way to lock this down. If you really have sensitive information that you cannot risk to get compromised, I suggest to keep it on the server side. Server-side environments are a lot more secure, or are supposed to be a lot more secure, and should work better. If you do have to store data in the browser, consider building a dedicated storage origin. Consider building this iframe-based approach where you have private.restocade.com or storage.example.com or whatever, where you actually keep that data. And then finally, if it's that sensitive, you probably need to think about offline access or direct access as well. And that's where encryption comes into play, where you can actually encrypt the data before storing it to ensure that if somebody steals it, they cannot easily access the data without doing a lot of other nasty things as well. I mentioned code examples throughout the podcast, so you can actually go to this page, pragmaticwebsecurity.com/talks/browser secrets. It's also going to be available in the metadata of the podcast, so you'll be able to find it. And if you can't, just send me an email and I'll point you to the right direction. On the page, you can find a set of slides, so you can refer to the images later on. You can also find a cheat sheet, which gives you a very nice overview of the different patterns, their benefits, their pros and cons. And there's also a link to the code examples that actually show you all of this in practice, so you can see how this Web Crypto API actually works. You can see how the browser-based isolation works, who does what, and how you can use that for security. I also encourage you to follow me on Twitter. I do tweet about security relevant things, modern security things, incidents, lessons learned, stuff like that. And I'm also on LinkedIn, so I would be happy to connect with you on there. And if you have any questions, don't hesitate to shoot me an email on philip@pragmaticwebsecurity.com.
Wanted to thank you again for coming in and presenting. This is fantastic. I think your cheat sheet also is pretty good, by the way. So I will make a link to that direct also in the podcast.
All right, that's awesome. Thank you for that.
Yeah.